Yeah, so we're going to be using something called the principle of inclusion-exclusion. And oftentimes, so this is more like of an advanced counting technique that's more used in like more difficult competitions like the AMC 10 or the AME. But like this is like a basic example on how you would apply principle of inclusion-exclusion. Since this is a long like term, you'll often see people abbreviate it as like PIE, like PIE, principle of inclusion and exclusion. So the concept of PIE is actually pretty simple. So like we can apply it to this problem. The idea is, let's first look at these like kids like one by one, right? So the first child calls every 3 days. So every 3 days. Notice that we know that there are 365 days in a year, right? Like that's we all know that, assuming it's not a leap year. So we notice that actually, let's go back to the question, right? The question asks, on how many days during the next year did she not receive a phone call from any of her grandchildren? So instead, we're going to also do something called complementary counting, which is basically counting what we don't want and just subtracting it from like the total number of possibilities. So instead of counting the number of ways she did not receive any phone calls, we can find the probability, not probability, instead of finding the number of ways she did not receive, the number of days she did not receive any phone calls, we can instead find the number of days she received at least one phone call and subtract that from 365. And we'll see why this is helpful in a minute. So for the child that calls every 3 days, there are 365 days, right? So if I do 365 divided by 3, I'm going to get something like 121 with a remainder of 2. So that tells us that the first grandchild is going to call on 121 of the days. So first grandchild is going to call on 121 of the days. And we can kind of do a similar idea for like the second grandchild. The second grandchild calls every 4 days, right? So if there are 365 days in the year, and they're going to call every 4 days, you do 365 over 4, which gives 91 with a remainder of 1. So that tells us that the second grandchild is going to call on 91 of these days. Now, the third grandchild we're given calls every 5 days. So if there are 365 days in the year, we do 365 divided by 5, which gives us 73. So the third grandchild is going to call on 73 days of the entire year. So if we wanted to find the number of days in which at least one grandchild called, like we might think, oh, we could just add these 3 together, right? We would just do 121 plus 91 plus 73, and then take that value, subtract it from 365 to get our answer. But it turns out like we can't like do that. Like it's not that simple. We have to like correct for overcounting, and this is what PIE does. Because, for example, on the 12th day, the first grandchild is going to call because 12 is divisible by 3. The second grandchild is also going to call because 12 is also divisible by 4. So, but then that means we're going to like count this day 2 times, but we only want to count the day 1 time, right? Because like the 12th day, that only counts as 1 day, even though multiple grandchildren called on that day, we're only treating it as like 1 day, which is why we have to like subtract out overcounting. So that means we have to subtract out the cases when when 2 children call and 3 children call. So kind of like that. So a lot of the times for these questions, it's a good idea to like draw a Venn diagram to like kind of visualize how it works. So if you have like a Venn diagram, the first child calls every 3 days. So every 3 days. The next one calls every 4 days. The next one calls every 5 days. You can kind of think of it as like overcounting, because for the 3 days, we got 121, right? We found that the first grandchild will call on 121 of the days. So this represents like this like portion of the Venn diagram. Now for the second child, they're going to call on 91 of the days. So they call every 4 days. Well, that's going to count this portion of the Venn diagram. And now for the third child, they're going to call every 5 days. And that's going to represent this portion of the Venn diagram. And maybe this visual representation kind of gives us a better understanding of why we overcounted, because notice that like these this like yellow region like in the middle is kind of like counted by like multiple of the regions, and we don't want to count them so many times. We want to count them exactly one time, which is why we have to use PIE. So normally we would do 121 plus 91 plus 73, but we have to subtract off like the number of days in which both the first and the second grandchild call. So the first and the second grandchild call every 12 days, right? Every 12 days. So we would do 365 over 12. That would give 30 with a remainder of 5. So we have to take out 30. Now we have to subtract off the cases when the first grandchild and the third grandchild call. So that's like every 3 days and every 5 days. So every 15 days, basically. So we would do 365 divided by 15. That would result in 24. And finally, we need to subtract out the cases when the second and the third child both call on the same day. So every 4 days, every 5 days, so every 20 days. So we would do 365 divided by 20, and we would get like 18 with a remainder of 5. But it turns out we're actually still not done yet, because like we notice that like we're almost done with the problem, but we have to take a look at this middle region, right? This middle overlap region that's covered by all 3 possibilities. Yeah, so now we have to actually add back 6, because this middle region, right, it was counted 3 times when we did this sum here, but then we also subtracted it 3 times when we subtracted here. So we added 3 times, we subtracted 3 times, so we basically didn't count it at all. So we need to add it back in. So that occurs when all 3 children visit. So they visit every 3, 4, 5 days. So this essentially means they visit every 60 days. So you would do 365 divided by 60, which means there are 6 days in which all 3 grandchildren visited, or all 3 grandchildren called the grandmother. And finally, this would represent our final value, this final sum. So if we were to calculate this out, a 121 plus 91, that would give us 212 plus 73. That gives 285. Then we do 285 minus 30 minus 24 minus 18 plus 6. So it turns out if you were to calculate that, that's minus 72. So 285 minus 72, that's 213. So 213, then you add on 6 at the end, so you get 219. But 219, you'll see it's not in our answer choices, and that's because we counted the number of ways in which at least one child called, but we want to find the number of days in which no children called. So we would take 365 and we would subtract off 219, and that would give us 146. So then that would be choice D.